Okay, good morning everybody who is just logging in. We're just going to wait a couple minutes here for the rest of the folks. People are pouring in here and I don't want anybody to miss out on much of the presentation. We don't have a very long presentation this morning. It's short and sweet. Just try to get to a few conversation points and we'll have a good question and answer session toward the end. But just a minute or two here, give everybody a little bit of grace logging in. And we will get started here in just a couple minutes. We're getting up to our attendee head count here, so I feel pretty comfortable. We'll get started right on time. So just a couple minutes. It's one-way audio, so nobody can hear you, so don't worry. Nothing is wrong. You are all on mute. We'll have a question and answer session toward the end where you guys can answer all your questions. My name is Chris Carbajal, Vice President of Engineering here at Pyramid Communications. I'll be doing the presentation this morning. And like I said, we will get started here in just a couple of minutes, so hang tight. Okay, we're going to go ahead and get started. Good morning, everybody, and thank you for taking time out of your schedule to attend our webinar this morning. And welcome to another Pyramid Communications webinar. We try to do these every so often when we have something of interest to discuss and get the information out to our dealers and users. Guys, my name is Chris Carbajal. I'm our Vice President of Engineering here. I am excited to talk about this presentation today. We've got a lot of new information to give out. Some of you probably know bits and pieces about it. You may know the whole story, but we're going to go over a little bit of a recap of why we did some of this VHF rule changes and why we worked on it for so long, and a little bit of recap on vehicular repeaters and things like that. So as you're joining, you are in a one-way audio scenario, so you can hear me, but I can't hear you guys, and that's just okay because we don't want any distractions, and we'll have a question and answer session toward the end. So we're going to go ahead and get started here. This is being recorded, so we will have this available for download afterward. A little bit of housekeeping as we get started. All of you guys will be muted. I suppose it's your microphones that will be muted. You cannot talk. You can hear me. There will be a question and answer session at the end of the presentation. Use the chat or the, even better, the questions toolbar in your GoToMeeting tray, your little system tray there that says GoToMeeting or GoToWebinar. Use the questions or the chat if you need to send in a question. Since we can't hear you, this is the best way to get your question in. I may not stop to answer your question right away, but I promise I will get to it toward the end when we have a more of an open session. So if you have something pressing that you want to ask in the middle, feel free to launch it out there. We can see it on our end. There's a few of us here that are administering the questions that are coming in, and we will keep track of them and make sure that they get answered. So, welcome again. We're going to be talking about something very, very close to my sphere of technical side of things here at Pyramid, and what we're going to talk about is our vehicular repeater and some of the changes that have recently come about in the frequency licensing for VHF vehicular repeaters. As we get started, and people are still filing in, so a little bit this is going to be recap, don't feel bad if you're just coming in late. But I just wanted to go over a little bit about why vehicular repeaters are important. I mean, I think we all know, but if you're new to the radio world or new to Pyramid products, vehicular repeaters are an important part of that mission-critical coverage on scene. They provide that coverage for portable radio users when they go into buildings, or if you're, law enforcement, when you go out on a foot pursuit or on a traffic stop and you don't normally have portable coverage, the vehicular repeater is what fills that gap and extends the portable coverage to the portable radio. So it's a pretty important piece of the life safety equipment that an officer or a firefighter carries. Not much different than a fire hose or a gun or anything else that they have. It's just a critical piece of their toolbox. The way that the vehicular repeater works, for recap, is that it's mounted in the vehicle. It's an in-vehicle solution, and it hooks up to the mobile radio in the vehicle. And we assume that most mobile radios, or all first responder vehicles, have a mobile radio. So we attach to that mobile radio with an interface cable, which we make interface cables pre-made from the factory for all the popular Motorola, Kenwood, Harris, Tate, all the popular mobile radios. We have all those pre-made cables. So the interface is rather simple, but the point of the Pyramid is to extend the coverage to the portable radio user. Now, the mobile radio has 50 or 100 watts, let's say. The portable radio is only 2 to 5 watts. So obviously you have a disadvantage of both power output and the type of antenna that you have in your mobile radio with the rubber, or your portable radio with a rubber duck, versus your mobile radio with a gain or a quarter wave antenna mounted on a nice ground plane. So the mobile radio all around works more efficiently, and what the vehicular repeater does is it gives the portable radio user the exact same coverage as the mobile radio in the vehicle by relaying all of the traffic from the portable through the mobile radio in the car. So effectively, that portable radio user has a couple of miles, best case, of coverage from their vehicle to go into buildings, to go on a foot chase after the bad guy, or whatever the case might be, climbing up a telephone wire, or whatever it might be. So that's what the vehicular repeater does, and it is a bidirectional link. So traffic that comes into the mobile radio gets relayed out a low-power transmitter and the vehicular repeater to the low-power portable radio, again giving it that same coverage as the mobile radio. So again, welcome those of you who are just joining. My name is Chris Carball with Pyramid Communications. We've almost got a full house here, and I just want to welcome you. Haven't missed anything. We're just doing a little recap of the vehicular repeaters and a little bit of how they work. I think most people know this part, but I just wanted to kind of fortify our topic today. So just to kind of overview, the vehicular repeater connects to the agency's mobile radio, and it relays bidirectional traffic through the mobile radio to the mobile radio system, effectively giving portable radios equal coverage to the mobile radio and its 50 or 100 watt transceiver. So, this is not a presentation on exactly how vehicular repeaters work, but I thought it was good just to recap. Now, one of the problems that we've run into over the years is with VHF mobile radios and VHF portable radios, and consequently VHF Pyramid vehicular repeaters. If your mobile radio is VHF and your agency or customer has VHF portable radios, the natural progression would be to put in a VHF vehicular repeater to allow them to use the same portable radio while they are outside their vehicle that they would use when they're in town, using the main trunk system or repeater system that's in their town. So the challenge is when you have a mobile radio that's high power and relatively high power, even if it's 25, 50, or 100 watts, in close proximity with a vehicular repeater, which is a radio in itself. It has a 2-watt transceiver in it, and they're both mounted within a few feet of each other in the vehicle. How do you keep the high-power mobile radio from interfering with the Pyramid that's mounted in the same vehicle? And I think we've all, been in RF interference scenarios, whether you're dealing with something at a site or you're dealing with something in a building or with an adjacent transmitter. These things are challenging, and obviously there are filters that you can put in to keep the two from interfering with each other, and there's frequency separation or antenna separation. But so you really have 3 components. You've got filtering, you have frequency separation, you have antenna separation. We'll start with the last. Antenna separation is often difficult to get in a vehicle because it's a vehicle. You only have a maximum of a dozen feet that you could put the antennas away from each other, best case scenario. So and you're not going to put an antenna for the mobile radio on the trunk and a vehicular repeater on the back bumper. So realistically, you're going to get 6 feet of separation, best case, on a vehicle. And so again, without any filtering, that's not really good enough to keep the 2 units from interfering with each other. So as we know, going back to the other 2 points, frequency separation and filters are really the 2 ways to keep the 2 radio types, the mobile radio and the vehicular repeater radio, from interfering with each other. So in our world, in our public safety world, the APCO has a band plan, or the FCC has a band plan coordinated through APCO that's about 150 to 159 for public safety and VHF. And Pyramid has a set of filters that can get you as close as 2 megahertz from your mobile radio frequencies. So the Pyramid filters can allow you to put the Pyramid on a frequency that's as close as 2 megahertz from the mobile radio frequency. Now, VHF being a very common public safety band, agencies oftentimes have all kinds of radio frequencies inside their mobile radio. They've got their own municipal frequencies. They've got the town next door. They have mutual aid with the state or Forest Service and everything in between. Dog catcher, street sweeping. Everybody's in this mobile radio, and we have to make sure that the Pyramid is away from all of those different frequencies in the mobile radio, so that we can ensure guaranteed interference-free coverage to portable radio users when they're outside of the vehicle. So there's some serious challenges there by just saying, oh, we can accomplish this with frequency separation and filtering. So frequency separation is also, so my point of saying, there are so many different frequencies in the mobile radio, whether that's mutual aid or your own agency's frequencies, is that there's just not enough room in the 150 to 159 band oftentimes to even get 2 to 5 megahertz of separation. So our solution was to sort of follow this path and do our best to get that. And it didn't work for everybody, and the filters are what they are. Filtering technology is great, but we're still working in the trunk of a vehicle or under the seat of a fire truck, so the filters have to be relatively small. So we're not talking about filters that you would normally put at a tower site that can get hundreds of kilohertz of separation with decent isolation. We can't put VHF filters that you have to tow behind the vehicle in a trailer. They're so large. It has to be moderately small. So the challenge is, how do we get enough frequency separation with the filter technology that'll fit in a mobile environment? We struggle with that. There wasn't really a good way to do it other than to seek more frequencies or more spectrum for vehicular repeaters in other parts of the VHF band. Just to kind of recap on the filtering technology that we have, Pyramid offers two different filters that go into a vehicular repeater system. The first is a bandpass filter. That goes in series with the antenna to the SVR, whether that's an SVR 200 as shown in this diagram, or an SVR 250 or a P25 unit. It's all the same. RF is RF, no matter what type of unit you're using from Pyramid. And this filter is effectively a bandpass. It's going to pass the frequency of the Pyramid and filter out all of those mobile frequencies. And then, probably equally or more important, we have a notch filter on the mobile radio feed line. And this notch filter is tuned to the Pyramid frequency, and its purpose in life is to filter out the phase noise that the mobile radio inherently generates across the VHF band while transmitting. And it keeps the phase noise from getting to the antenna and propagating out at the frequency of the vehicular repeater. So in the next slide, we'll actually be able to see if your vehicular repeater was at 160.61, just an arbitrary frequency for this illustration, and your mobile radio was at 158.61, which is 2 megahertz of separation. This is with our best filter. We would have close to 30 dB of isolation and virtually no insertion loss. So it would have no effect on the mobile radio's normal operation, but would keep the phase noise down by a factor of 30 dB from getting outside of the antenna and actually getting an opportunity to interfere with the Pyramid. So this combination has worked really well, but the challenge is still there are not enough frequencies in the 150 to 159 band. So again, the radios are full of frequencies. We have to maintain that 2 megahertz bandwidth from all frequencies in the mobile radio, not just their primary dispatch frequency where they intend to use the vehicular repeater, because once you add filters, the filters are always there. They don't have an on and off switch, and they're always going to be present on that antenna. So we need to make sure that we maintain that minimum 2 megahertz separation all the time, not just when or on the frequencies that they intend to use the Pyramid on. So when you go in to look at a customer's mobile radio, or we have some end users on this, when you're looking at your own radio, the first thing to do before even thinking about doing VHF in band or going out for licensing a new frequency is to assess the frequencies that you have programmed into your mobile radio, and then start seeking a Pyramid or a simplex frequency for the Pyramid that's at least 2 megahertz away from any of those frequencies. And then you can find a happy home for your Pyramid that will not have any contention with the mobile radio frequencies once you add all of the filtering that's required. Now again, traditionally the challenge is there weren't enough channels in the 150 to 159 band to facilitate the Pyramid vehicular repeaters and also maintain that 2 to 5 megahertz frequency separation. So adding the filters help, but the filters have limitations because they're constrained by size. We're talking mobile cavities here. We're not talking tower site style cavities that are very large. So we're talking, there's always a trade-off. The smaller the filter, the less performance you're going to get out of it. Now, we make our own filters here, so we custom tailor them for every order so that we can get the most separation, the most rejection from the mobile radio. However, you're still limited by the size of the filter. So, that's just a recap of kind of what challenges we were up against and how the vehicular repeaters work, just to kind of get up to this point. Is we have spent the last 6 years seeking an FCC rule change. Previous to this, if you didn't have a frequency within the 151 or 150 to 159 band that would fit that minimum 2 megahertz separation requirement, your only option was to go and try to get a waiver on another frequency that was outside that, 160 or above, in this case, because there's really nothing available below 150, that would get you enough separation so that the filters could work in conjunction with the pool of frequencies that you have in the mobile radio. So that all sounds good, but the reality is the waiver process was difficult and most of the time impossible to achieve. You could be on waiting for years to get a waiver just to be denied. So a lot of agencies, in lieu of doing this, just did without the on-scene coverage or went to different technology to try to solve their lack of portable coverage. So Pyramid has gone working with our FCC attorney and through the coordinators, and spent the last 6 years standing up for the agencies that were lacking this coverage. And really the heart behind this was to get coverage for those, because we were hearing it from our end users and from our dealers about agencies who just they're in limbo. They can't get a frequency, and they're not. And a lot of our customers aren't state agencies. Of course, we've got a large constituent of state highway patrols who use our product, but they usually have enough pull to get a frequency without too much difficulty. I mean, it's not always easy, but the smaller agencies have a really tough time. They don't have the resources or the technical abilities to be out and petitioning for waivers, or it's very difficult. So we took a stand to try to help that cause, and that's really why we've been motivated to seek these rule changes over the past 6 years. So in 2010, and then really coming into action in 2011, we had been petitioning the FCC for some new frequencies in the 173 megahertz band. And the short part of the story is that through the series of meetings at the FCC in Washington D.C. and going through the due process through the FCC's what do they call it, the waiver, not the waiver process, but the rulemaking process, where we put out our proposals and public comment comes back, and we come down and whittled these frequencies down to 6 potential candidates that are currently used for telemetry, but not used everywhere in the United States. And our goal was not to take them away from the incumbent users, but to share them where they were available. And so at the beginning of this year, we were actually granted the new rulemaking was adopted, and we have 6 new frequencies for the SVRs, and there are these 6 frequencies here. They are shared with the existing telemetry users. We're not secondary to them. We're actually equal, but it is a first come, first serve. So if there are telemetry users, and these are utilities, waterways, water districts, and other people like that who use them for monitoring site equipment, waterways, dams, and things like that. If they're using them, all 6 of them in your area, well, then they're not available for you, because it's first come, first serve. And we'll talk a little bit about how that licensing goes as we move through the presentation here. But the bottom line is, we have something now. At least previous to this, we had nothing. So we had no options for getting the vehicular repeater separation that we needed from a technical standpoint. But now we have 6 new frequencies that we have access to if they're available. And again, a lot of our agencies are in rural areas where at least one of these frequencies is available. So you have to do your research, and you have to work with a coordinator who understands this. And again, we'll get to this as time goes on. So I think it's a big win for our industry and for our users who use vehicular repeaters and who have lived without the vehicular repeaters for so many years. It was not a particularly exciting process because it moved very slow, but we understand that the FCC and the incumbent users on these frequencies want to make sure that we don't cause any harmful interference or do something that's too rash, which is going to totally obstruct or hinder their communication. So and that wasn't our intent. Our intent was to share friendly with the incumbent users. So big win for our industry and for Pyramid on these frequencies. I've personally worked on the project from the beginning, and I'm very, very happy with the way that things have gone, and so we're going to talk a little bit more about the new rules. So I think that's probably why most of you guys are here. So the new rules, how do they work? So we've got these 6 new frequencies. Life is great for licensing vehicular repeaters on there. Now the new frequencies are telemetry frequencies in the business industrial pool, and they are now available for public safety to license as well. Again, since they were business industrial frequencies to begin with, they not only can public safety get them, business and industrial can also get them. So that means that they can be used for their original use, which is telemetry. They could also be licensed for vehicular repeater voice use for public safety, and vehicular repeater voice use for business and industrial. So there's it's still open for many different industries here. The biggest, I think, the most significant change to the frequencies themselves is they were originally 6.25 kilohertz data frequencies, and the FCC, through a lot of engineering work in the background, has figured out a way and to license these as narrowband, traditional, 12.5 kilohertz, which with reality in VHF it's 11.25 voice frequencies. So we're actually able to license them as standard MO3. Now, vehicular repeaters are mobile devices, so they do fall under the MO3 station class. There are some caveats to the new rules. So, and this is really important. So if you're taking notes, this is one of the big ones. Minimum of 50 units per channel before you license a second channel. Okay, so before you can get another channel for your user, you have to prove that you have a build-out of 50 vehicular repeaters, not vehicular repeaters and portables, but actually 50 sets, for lack of better terms, on that channel before you can apply for a second one. Now, in the old days, there weren't any restrictions on these for the 150 channels, or even if you got a waiver on a 173 channel. And I've seen customers license, three vehicular repeater frequencies for one small town, just so they can break it up, so they didn't have so many people on one channel and they could separate their scenes. Well, you're not going to be able to do that here. You are going to have to build out that that channel with 50 vehicular repeaters before you can get a second channel. And the point is here is that the FCC does not want the vehicular repeater users to go and hog up an entire group of 6 frequencies when they're not actually being utilized to their potential. So it really makes sense, and I think it's fair to both of us. We're getting something here, and we don't obviously want to completely lock out the telemetry guys or the business guys. So and most of this is because the vehicular repeaters and telemetry are not compatible technologies, right? I mean, telemetry is data. Telemetry can't tell if there's somebody using a channel for voice, and voice people aren't going to necessarily listen for the telemetry users before they key up. There's no way to really, other than busy channel lockout, which isn't really, probably the best way. There's no surefire way to protect the two sharing one channel, so they're considered exclusive. And once somebody has a channel in your area, you have it for vehicular repeaters or telemetry. So you wouldn't want, this is why the previous bullet point of requiring a loading of 50 vehicles is so important, because you wouldn't want somebody to come in and exclusively grab up all 6 channels in one area and prohibit another type of licensee from coming in and using it for their purposes. So, it's all around a pretty fair ruling. The next point of interest is there's a maximum 80-kilometer radius from your center coordinates and your license that you can use the frequency. And the intent here is again, so that we can prevent, large, wide area, multi-county or statewide systems from taking a channel for an entire state. There are provisions for statewide users that are greater than 80 kilometers. However, they follow as secondary users on the channel, so they don't have primary access. So however, they could get a frequency. They wouldn't have it exclusively for them. They would be considered a secondary user to somebody who had a smaller coverage contour. So again, it's still great for the municipalities and areas that are smaller than 80 kilometers, and I suppose if you had a need for more than that 80 kilometer, you may be able to break that up into multiple frequencies if you could justify the different offices or different center coordinates for that agency. You'd have to work with the coordinator on that. But so the LMCC was an integral group in coming up with the coordination rules or the coordination protocols for the rulemaking. And essentially, the coordination process goes like this. If you're applying for a new frequency and the distance between your SVR center coordinate and the data telemetry is bigger than 160 kilometers, you're going to get the frequency. So if you look at a frequency and there's somebody with a data telemetry transceiver already licensed for the frequency, but they're more than 160 kilometers away, well, there's no question that you're not going to interfere with each other. The vehicular repeaters are 2 watts themselves. Portable radios are 5 watts. So the maximum you're going to have here is a couple of miles of rural coverage from the vehicle itself, and now vehicles are moving, so there's a big buffer zone here so that we don't actually cause interference. But the point is that step one, if you're further than 160 kilometers from an incumbent user using data, then we're safe. Number two, if you happen to be closer, and they don't overlap, but there are some, there's a potential for it, you have to get a sign-off from the incumbent user. Okay, so again, if the frequency coordinator analyzes the frequency, finds that you are too close, you're going to have to get a reciprocal agreement from the incumbent user stating that their antenna is pointed in a different direction, so it's never really going to interfere. And whether you're ever going to get anything like that, I don't really know. But the reality of it is, they probably say no anyway. But I don't know. That's just my personal opinion. But that's the process. This is the coordination protocol and the litmus test for actually getting one of those frequencies. I'm just looking at some of the questions here. Okay, so here's kind of a couple of the things that we wanted to really hit on in this presentation, and I hope this is all, making sense so far. And we're about a half an hour in, and again, I wanted to keep it, under 45 minutes just to respect your all's time. But the confusion that we've run into so far is the criteria we talked about earlier that said there's a minimum of 50 units per channel before you can license the second channel is written very funny in the rule, and it's not unclear, but it could be unclear if you didn't really slow down and read it. And there's been some confusion about this even through the coordination community in the very beginning. And I just wanted to, and I've heard it from dealers where they went to a coordinator and the coordinator said, no, you have to have 50 vehicles before you can get this channel. And I thought, well, that's an interesting one. I've never heard that. But that's not true. So the rule doesn't say you have to have 50 vehicles before you can get the channel. The rule says you have to have 50 vehicles before you can get a second channel. So again, it's not a minimum vehicles that you have to have before you can get one channel. It's a minimum number of vehicles you have to have on your first channel before you can get a second channel. So if you're, and I think the coordinators are ironed out, and have this figured out by now. There's been some conversation on it, but the point is, if you hear any of that, some coordinators have more experience with the rule change than others. You can stand firm and say, no, that's not true. The truth of the matter is, if you want 2 frequencies, you're going to have to justify 50 units on the first frequency before you can get the second. It has nothing to do with you obtaining the first frequency. You can have 2 units and get 1 frequency. There is no minimum per se to get a license on one of these 6 channels. Okay, now the second question that came up, and this one got kicked up to the FCC as part of a post question and answer to them, and that is, can all coordinators license these channels? Because I think we all have our favorite coordinators, but obviously APCO is one of the coordinators that would have first rights to coordinate public safety frequencies, right? So, but the answer to the question is, if you're a business and industry user, then business and industry coordinators have to certify the applications for business and industrial users. That doesn't mean that you, and I don't know why you would go to APCO to license a business and industry frequency, but on the other side of things, if you're a public safety user, normally you'd go through APCO, but maybe you as a dealer have a relationship with another coordinator that you like to run all of your frequency coordinations through. You can license a public safety frequency through a non-public safety coordinator. However, that public safety coordinator has to certify the frequency through a public safety coordinator. So in other words, they can do all the legwork, they can do the engineering, they can do the paperwork and that sort of thing, but the final signature, the final sign-off comes from a public safety coordinator. So, you know, you can still use whoever you choose. It's just whichever pool you're applying from, whether that's business or public safety. There will be a coordinator of like kind doing the final sign-off or certification of the application before it gets submitted to the FCC. So, you know, that's pretty straightforward. It doesn't really preclude you from using any particular coordinator, so you get to still use your favorite, which I think is a good thing. Some coordinators are better at this process than others, and I'm not picking any favorites. Some people have more experience with it, and you know, hopefully over time everybody will have experience with it, so it won't really matter. But at this point, you know, there's been a few coordinators that have been very involved in the process of getting this rulemaking passed, and thus they're probably the best ones to go to if you're looking for a frequency, and we'll get to that in just a minute. So equipment lists, just kind of recapping what you would need, and this, you know, falls kind of out of context of the licensing, but now that we understand the licensing caveats, but there's not really that many. You know, there's the 50 unit loading before you can get a second frequency, and you know, that's pretty much the only strange one that's probably a little out of the ordinary from normal licensing. But the equipment that you would need is your SVR. You're still going to need a bandpass filter, and you're still going to need a notch filter. Those are three things that you're going to need. Definitely no questions asked, even though you have, let's say, 18 megahertz of separation now between your mobile frequencies down at 150 to 159 and your pyramid frequency up in the 173 on one of these new 6 channels. You're still going to need the filter. So even though we've successfully petitioned and obtained these frequencies for public safety users, it doesn't mean that now we have so much frequency separation that we don't need any of the filters anymore. No, that's still not true. There's still enough interference. We're still in a car or a truck or a fire truck, whatever it might be, an ambulance. We're still in this tight, limited space where there's enough phase noise and RF energy coupling between the two antennas that we need filtering. There's just no questions about it. And if you go onto our website, we've got in the filtering section some graphs that actually show the amount of descents based on antenna separation and frequency separation. The proof is in the pudding, so to speak, where the interference factor, even at 18 megahertz or 20 megahertz from 150 to 173, is significant and can diminish your coverage to 1,000 feet of coverage if you don't have the filters. Where if you're running the filters, you can have virtually no descents. Maximizing the complete potential of the vehicle repeater in an open space can get 2 miles of coverage from your vehicle. So you need the vehicle repeater, obviously. That's your repeater. You need the 2 filters, and you need antenna separation. Now, antenna separation is sort of a subjective thing. What is good antenna separation? What is bad antenna separation? Good antenna separation whether you're running your Pyramids crossband VHF to UHF or in-band VHF to VHF or UHF to UHF, good antenna separation is separate ground planes. So not both mounted on the hood, or not the hood, who mounts their antennas on the hood, not both mounted on the roof of the vehicle or not both mounted on the trunk. You want one mounted on the trunk, one mounted on the roof of the vehicle so that they're on separate ground planes, and you want them as far away from each other as possible. Putting maybe the mobile radio antenna on the trunk and the SVR antenna in front of the light bar or vice versa. You don't want them on the same ground plane. You don't want them even 2 feet away from each other. That's way too close. You know, you're still going to degrade the performance of the vehicular repeater and cause potential interference and damage, even damage to the vehicular repeater or the mobile radio by inducing so much energy. The filters can only do so much for you. So just good practices, best practices of good RF are still required. We still need antenna separation, just like you would if you were going to put 2 high-power mobile radios in a vehicle together. You know, get those antennas 6 feet away from each other on different ground planes. And I can't stress this enough for all your Pyramid installs. Whether you're going 800 megahertz to VHF, get those antennas away from each other. The most common technical support trial that we run through is the antennas are too close. And furthermore, probably the most common repair item that we go through is the antennas are too close and they cause some damage to a front-end component or an RF antenna switch or something like that in the Pyramid that causes units to come in. You know, it could take a year for the part to blow up, so you're probably going to be out of warranty by the time it blows up. But you know, you want to get those antennas away from each other just for good practices. So that's just important. I wanted to get on my little soapbox there so everybody just kind of know our thoughts on that. So you know, our recommendations if you're starting a new system, VHF in-band, is understand the basics of VHF in-band. Understand what filters are required, understand the frequency separation requirements, research your customer's mobile radio. So in other words, look at the code plug, look at the personality of that mobile radio, look at all the frequencies, understand where they are. You might be surprised, you know, when you look at agencies, particularly in the fire agencies, they'll have mutual aid, forestry frequencies, and they're up at 173. So you could still run into potential problems trying to license one of these 6 new frequencies if your customer happens to have frequencies in their mobile radio that are also up in the 172 or 173 megahertz band. So, you know, just do your research, find out what fits, understand that we need at least 2 megahertz of separation. If you can get more than 2 megahertz of separation, let me go back. If you can get more than 5 megahertz of separation, you can get a less expensive notch filter from Pyramid, so you don't have to buy our most selective narrow notch filter. You can get a little cheaper solution. So all around, that's good, saves your customer a little bit of money. But do your research, understand how it is. We've got a lot of white papers and even some stuff on our website on it. You can contact you contact me, you can contact Art, our tech support lead here at Pyramid, and he can get you those articles if you're interested. But we've got a lot of paperwork on that. This is not new for us. We've been doing VHF in-band for many years. We've been you know, manufacture our own filters and everything. So, you know, we've got a lot of experience with it. We've made our mistakes a long time ago. So, you know, this is all not new to us. It's all pretty straightforward. My second recommendation is to work with coordinators that have experience with the new Part 90 rules. You know, like I said, you can coordinate through anybody that you choose. You know, there's not any limitations on that. Ultimately, again, as I mentioned, one of those caveats, if it's public safety, then you know, a public safety coordinator ultimately has to certify the application before it gets submitted. But you can still go through any of your preferred coordinators, and really my recommendation is I would go through EWA. If you're not a member of EWA, they've got discount rates for their members. They have intimate experience with this rulemaking. They were an integral part of getting this rulemaking put together, and you know, we really appreciated the effort that they put in. But better yet, at the end of the day, they'll do a good job for you. They'll get you a frequency without having to ask you a million questions because they were involved in the rulemaking in the beginning. The same holds true to RadioSoft. They played an integral part in actually drafting the rules for the LMCC portion of the coordination protocol, and they're very capable of getting you a frequency quickly and easily. APCO as well, integral part of the rulemaking. So, again, use somebody who's familiar with it so you can get the application passed through without much resistance. This seems obvious, but Pyramid's not a coordinator. We can't help you license any channels. We're just going to deflect. This presentation, I'm not a coordinator. I worked many years here at Pyramid, obviously, and the past 6 years of my career here working on this particular initiative. So I know, but I can't help you. None of us here really get involved in the licensing process. So the best thing to do is to talk to somebody who has real-world experience. That would be one of these coordinators here. So with that, we're going to leave just a couple minutes for the Q&A. I wanted to give some special thanks to our FCC attorney who has been with us for many, many years, representing us to the FCC, and that's Alan Tillis and Shulman Rogers. He did a great job facilitating this rulemaking through the FCC process. Mark Crosby at EWA, also great asset in getting this proposal passed. Peter Moncure at RadioSoft, our loyal dealers, manufacturers, reps, agencies, who all supported the rulemaking. I think we all had a hand in this, through putting in, filing your public comments, rounding up your end users to file public comments, and supporting us through the process. For those of you who've done it, you know the process. It's really just a series of back and forth with the FCC, and they really want to make sure that they're doing the right thing when they do these new rulemakings, and they do that with getting public feedback. And so your feedback that you gave the FCC through this process was critical. We couldn't have done it without you guys, so we really appreciate that. And APCO and LMCC, we just appreciate their support, and LMCC in coming up with all the coordination rules and asking the tough questions to the FCC and clarifying exactly how this is all going to work. So we just appreciate everybody putting in. What I'd like to do now is just open this up for question and answers, and I think we have a couple of them here. So let me sift through, but use the questions. There's a questions toolbar in your GoToMeeting. Use that, and let's ask a few questions, and don't all drop out at one time. It's if there's a few questions that you never know, there might be something helpful for you. So let me read through some of these here. Again, we can have these slides to the PowerPoint for sure. That would not be a problem, Kevin. I appreciate the question. We'll try to distribute that out to you via email. We'll have a link to the recording and to the PowerPoint presentation for you. So thanks for that question. Gary, same question. Gary Gray, appreciate that. Martin, you asked a question about antennas. So do the portable radio antennas have the bandwidth to do 150 and 173? Normally, yes, but I mean, in general, portable antennas are just marginal at best anyways. They're rubber duck antennas, and they don't really have a fantastic performance, just SWR-wise as they are. So, it's a helical antenna designed to be small. So, it's never going to compare to the performance of what you have on your mobile radio. So I would say the antenna is not very great to start out with. But the good news is we're not trying to get 10 miles from the car with the portable radio. We only need to get let's just use the 2-mile mark. The Pyramid outputs 2 watts. The portable outputs 5 watts. And part of the reason that works out to be balanced is that the portable radio has a lousy antenna. It's got this rubber duck antenna, and 5 watts makes up for that lousiness of the antenna. Where the Pyramid only does 2 watts, but it's got a nice quarter wave antenna mounted in the vehicle on a nice solid ground plane. So you have advantages there, and I think the 5 watts of the portable makes up for the deficiencies of its antenna. So hopefully that answers your question. Ken, so your question, you use these 173 channels in your mobile radio for mutual aid. Can you operate without a notch filter on the mobile radio without significant degradation? Maybe. Certainly you would not be able to use the Pyramid at the same time in the 173 band as you're using one of these mutual aid channels in your mobile radio at the same time. I don't think that that's what you're asking. I think what you're probably asking is because you happen to have these 173 channels on the mobile radio, obviously the filter would cause interference to those, but you'd want to use the Pyramid with your 150 channels most of the time, I'm guessing. So if the Pyramid was off and you didn't have a notch filter, sure, use one of those 173s, it won't cause any issue. If the Pyramid is on and you're using a 151 frequency without the notch filter, you're still going to have some interference, more than you would without or with the filter, of course. But you can, like I said, there's really 3 key components to keeping this desense or interference down, and that's antenna separation, frequency separation, or filters. So if you don't have the filter, then you have to make up for it on the antenna separation part, and you're going to have to move those antennas to the extreme. And we've seen them. We've seen people mount the vehicular repeater antenna up on the push bumper of the vehicle just to get a shadowing effect from the hood of the vehicle, and that could work. I mean, you're really just trying to knock down that phase noise. That's what the notch filter is doing, and you're cheating the lack of physical separation with that notch filter. So yeah, I think it could work without a notch. It's not going to be as good as with the notch, and you're going to have to be more creative with your antenna separation. But if that's all that you have, then that's all you can do. You're going to have to live with the less sensitive receiver. Are the bandpass filter, I have a question here from David. David, are the bandpass filter and band reject filter required for crossband, so VHF to low band? The answer is no. They're not required because you don't have the phase noise that's present being in the same band. However, I will say that antenna separation here is super important, especially with low band VHF. Low band is just a nasty band. It's typically high power, and you want to get those antennas as far away from each other as possible. I've seen low band transceivers turn on blinkers in vehicles. You know, this low band is just a tough band in general. You probably already know that, but you know, get the antennas as far away from each other as possible. We also manufacture a high pass filter that is not a bandpass or a reject, but it's actually a high pass filter, and it passes those VHF frequencies and attenuates all of the frequencies below 120 megahertz. So it blocks out all the low band. So look up in your Pyramid catalog the high pass filters. We have a 120 megahertz high pass filter. That would do you quite well. How do you get adequate separation on a 2-door pickup truck or small SUV? Skip asks. Good question. So understand you don't have a trunk, right? You're going to have to put something up on the hood. I think the best scenario, again, knowing that you know, you need separate ground planes, do a trunk lip mount, put it on the hood of the vehicle. That way, at least you get the separate ground plane. You can also use a phantom antenna. That is, you know, Antennex makes some. I know that Laird makes some of these. You know, all these brands. We don't represent any particular antenna company, but they make some low-profile antennas that are, you know, these little canisters. What's really cool about those is that they actually have a relatively tight bandwidth, so they act as a band pass filter of sorts. So you'll get less coupling between the antennas in tight situations. So if you are stuck on a fire truck of putting both antennas on the roof of the vehicle because there is no hood, let's say, and you can't put it because there's a ladder in the way somewhere else, use one of the, don't use 2 quarter waves, in other words. Use a quarter wave and a phantom antenna, and that'll actually reduce the coupling significantly. Let's see. Alex, you asked if these frequencies can be used in an SVR 252 full duplex configuration. Unfortunately not. These are simplex frequencies, so we didn't get any pairs. That's really not what we were looking for. So you'd have to go traditional full duplex licenses for this, or seek a pair of frequencies. Ken, I don't have your email address here, but if you're looking for units and talking about in-building coverage improvement, give me an email. My email address is Chris, C-H-R-I-S, at pyramidcom.com, and I can direct you to somebody who can talk to you about improving your coverage in buildings. Certainly is something we'd love to talk to you about. Okay, John, you've got a question about how long the application process takes. I don't know. We don't typically get involved with it. I can't imagine that it would take more than 30 days. The engineering, the background engineering part of it is required, so they do have to run some calculations. They have software to do that. That's what RadioSoft is a specialty for. That's their specialty claim to fame. So everybody runs the numbers first, just mathematically, to figure out where the interference possibilities are, and then there might be some more research. So I think it's going to vary depending upon other incumbents in your areas or other adjacent channels in your areas that might be within the 12.5 or 11.25 kilohertz bandwidth of the vehicle repeater. So it depends. Skip, you're asking the emissions designator for the pyramids. So they're standard 11K0F3E. So it's standard narrowband voice. You'll need to put that on your application. It does vary if you're in P25. There's some different ones for the digital modulation. Look in the service manuals, which are all available on Pyramid's website. They have the emissions designators for licensing purposes right in the front. And then don't forget to submit the FCC ID of the Pyramid product that you're licensing on your application. So, question came up here from David. David, can I briefly describe priority sampling and how it works? I can. It has nothing to do with this presentation, but it absolutely we can. The priority sampling is an analog how the Pyramid actually looks for 2 different things. So effectively, I'll back up a little bit. When the Pyramid is handling a call from base to portable, that means that your dispatcher is talking or somebody is talking on the dispatch channel, and the Pyramid is rebroadcasting on the simplex channel to the portable user. It samples. So in other words, it drops its transmitter for a very short period of time. And if you're using an SVR 200, you're talking about 50 milliseconds that drops out. If you're using an SVR 250, you're talking about 5 milliseconds that drops out. It's a very short amount of time. But it looks for 2 things. It looks for other pyramids, which might accidentally be in priority, trying to handle the same call. So it's a way of resolving a priority conflict if 2 pyramids happen to be handling the call at the same time. So that's one of its key purposes. And the second one is to look for portable radios that might be keying up, trying to talk back to the dispatcher. So if you have a long-winded dispatcher and they're sitting there talking about reading off license plate numbers or whatever it is, and some portable radio user starts getting shot at, the priority sampling is there so that the portable radio can key on top of that dispatcher, and the sampling will happen. We will see the portable radio carrier and the proper PL tone, and then we will key up the mobile radio and key on top of that dispatcher. And most of the time, as you know, with the console setup, the dispatcher is able to hear incoming traffic on the voting system simultaneously with its, while the dispatcher might be talking. So, that's what priority sampling does. So it samples during base to portable calls, and it samples to look for contention or conflict between other pyramids that might be in priority in the immediate area, and to look for portable radio priority so that we can allow an officer or firefighter to key up and talk back to dispatch. So that's it in a nutshell. Okay, any other questions that we have here? Because we are running out of questions. There weren't too many. I hope this was good for you guys. I appreciate you giving us an hour of your time. And if there are any questions, please feel free to email me or Michael Foley for the West Coast dealers here, or Seth Chandler for the East Coast dealers. We're happy to answer your questions. We're happy to work with you on getting you this presentation. Whatever you guys need, we're here to support you. Contact the coordinator who has experience with this, and let them know any of your licensing questions. I'm sure they're happy to help. These guys have been involved with this process for a long time. So thank you very much again, everybody, and we appreciate you spending the time with us this morning. And we're looking forward to talking with you all soon. Yes, it was recorded, Ron. We'll try to get the recording out via email. We just have to do some doctoring up of it and getting it ready to post online. So we'll put a link.